I add to your plate. Okay. So the thing is, I will still from at least once here and there, I'll ask you to uh, sketch what's happening based on what you read, because I think it's important for you to have that skill. Okay, so page 9. I want you to read because I think what students, when there's no word problem, students know, okay, I know how to solve this thing. I know how to solve for all sides, all angles. I got this, Mr. Dirksen. I'm good. But the problem is, are you able to just solve the thing that they're after, right? Like, are you able to answer the question? So I think I'm gonna give you some time now in this in the notes. This is on your own, right? To work on pages 9 and 10. And notice that there's a lot of space, right? The reason why I left a lot of space is that I don't want you to erase your work. The work that you're about to do, you're not going to erase it. We're going to use the bottom part for me to correct it with you, okay? And if time allows, I might start cosine law already. I think I'm quite certain I will start it, and then we'll next week we'll resume, because next week is a short week again, 4 days only. Yay for you, right? Not for us. We're still here. So go for it, 9 and 10. So let's say I think we'll be okay with time if we do it that way. All right. So let's go to page 9, and we'll slowly go through it and highlight and do things that help you solve questions like these. What I don't like is that it flat out tells you use the sine law. I wish they wouldn't do that, right? It's like you should recognize that this is a sine law situation based on what's happening here, right? So the first thing that you should do is find this angle. You can call it angle T here, right? For you add letters as much as you want for the tower, right? So angle T is 180 minus 65 minus 80, and that is angle T is going to be 35 degrees. Okay, that would give you a mark already. If the province ever makes you do that in order to solve, that's what's happening. So this is 35 now, and so I have my pair. Okay, my known pair this is one of those that is hidden at first. Okay. So we go sine of 35. Always start with your pair, because then you're halfway there with your setup. And here you have to choose, right? What is it asking you to do? Determine the distance from Elliot's house to the tower. So from Elliot's house to the tower, they're asking for this side right here, this side length, which means you must use that angle. Okay, you have to use the angle across from it, not the 65. And then it turns out that it's just multiplying and dividing. This works for any triangle, even a right triangle, guys. Sine law, cosine law work for both types, oblique or right triangles. If you type this in, you get 4.29 kilometers. Boom, you're done. So this one was a pretty straightforward. I hope at least that's what you were supposed to get there. All right, keep going. 10. A pulley winch in an automotive shop is suspended from a ceiling by 2 support chains. One of the chains is 2.4 meters long, there it is, and forms an angle of 55 degrees with the ceiling. The second chain is 3.5 meters long. Use the sine law. I don't like that one. I'm going to have to get that out of the way. But determine the size of the angle that the second chain makes with the ceiling to the nearest degree. So you can call this, right? We can call this A if you want, or something, capital A. You can put a small letter in there, that's okay. So we have our pair. So that's why sine law can be used here, must be used in fact, right? So you start the same way. Sine of 55 over 3.5 meters. And then on the other side, sine of A, not just A, right? 2.4 meters. Bingo. That's a mark right there, guys. A mark right there, just the correct setup. And then this is a little different. You can't just, you have to cross multiply and divide, just like before. But what I do is I figure out what this is to the, and I use all decimals. If you don't want to use all decimals, use at least 4 or 5. Write them down, and then you can, then you should be fine. You won't be having any rounding issues. Okay, so 3.5. You better get something that starts with a 0, or else your calculator is going to complain. It won't be able to do it, which means you set it up wrong. Okay, or I made a mistake in writing my question, but usually I key it, so first check, right? And then my next step is angle A, just angle A, is sine inverse of 0.561 and continued, right? So I don't clear it on my screen, I just go shift sine equals, and it's 34.17 degrees. That's what I would prefer, but if you did 34 degrees, you are right, because the question did ask to the nearest degree. So now we have that angle. So now the question could ask, how far apart are those chains anchored to the ceiling, right? They could do a B part. It's like, no problem, I can find this angle because I have 2. And then repeat the process with the known pair, but now on this side, you're going to have sine of C over ceiling or something like that, right? Okay, let's keep going. Page 11. We're doing good with time, so I will show you how to sketch your own diagrams as well. Page 11. So you're camping at Lake St. George Provincial Park. He has taken 2 rowboats out onto a lake. How far will he have to row if he travels from point A to point B? Right, so it goes from here to there, and then to point C, and back to point A. So basically, what's the round trip distance? This calls for, I'm going to call this lowercase a, this side, and capital B is here, so I'm going to call this lowercase b. You could have called it X or Y, I don't care, okay? But you need to figure out all the sides. You need to figure out all sides here. So how do we do this? It's sine law. Why? Because I have a known pair in this situation. So I'm going to go sine of 113 over 1255. And that's in meters. And then I'm going to use this one, sine of 27, which is going to allow me, it's going to allow me to find side B. Right? So side B is 1255 times sine of 27 divided by sine of 113. And that gives you, oh, I'm on the wrong, oh no, that's good, 618.96 meters. Okay, so this is important, but it's not my final answer yet. It's not my final answer. Then I have to solve for side A. I need angle A for that, and I have 2 out of the 3, so I'm going to go 180 minus 27 minus 113. So angle A is 40 degrees. And this one is 40 here. I'm going to write it in. So I start with the same pair. I tend to do that. That's my method, right? And now I'm going to use sine of 40 to figure out side across from that, side A. So side A is 1255 times sine of 40 divided by sine of 113. And A is 876.37 meters. Does that make sense? It's slightly larger than 27, right? So look at the angles. This is the largest angle, should be the longest side. This is the second largest angle, should have the second longest side across from it, which is true, right? And then your smallest angle, which is 27, has this in front of it. We're not done yet, are we? Almost. Come on, like when are we done here? Round trip would be 1255 because it asks how far would you have to row. Okay, so we're going to add up all these answers, all the sides, basically finding the perimeter of the triangle, right? That would be 27, 50, and 33. Just over almost 3 kilometers actually, 2.7 kilometers. So I could do a vehicle finance on this. Hey, how much fuel would you need to travel if the fuel economy is 9.8 liters per 100 kilometers? Something like that. Anyways, let's keep going. Here, I'm going to add something, okay? So pay attention to this one. Second, sure. You're welcome. Okay. Fill the diagram. So you have to fill in the diagram, okay? So let's see if you did this right. Hot air balloon in Regina, Saskatchewan. His friends David and Eva, right, or Eva, are watching from the ground. They're standing 100 feet apart. So I hope you would know the 100 feet go right here. And I always like to make dots in all the corners, right? Next, Eva's 505 feet from the balloon. So the 505, goes here, right? 505 feet from her to the balloon. And what's the angle of elevation of David's line of sight to the balloon? What is it asking for? I hope you understand angle of elevation is always between the horizontal and the line of sight looking up, right? That is the angle of elevation. So for David, it would be this one right here. We can call this angle D for David, right? So let's go ahead and see if we can make this work. Do we have anything else? Oh, the 11 degrees, sorry. The angle between Charlie's line of sight to the two of them is 11 degrees. So from Charlie's line of sight, right, to both of them, that's 11. Let's put that in. That's very important or else we would be stuck, right? So there you have your pair. This 11 is across the 100, okay? So sine, let's start with that. Sine of 11 over 100 feet. And we do have the side across the angle we're interested in. So we're going to go sine of D, whatever you call this angle, over 505. So this is harder for students to do the inverse. Maybe not today, maybe because today you've done a bunch, but later on, this is the hardest one. So you should have something on your study sheet with this. So it's 505 times sine of 11, right? Because you multiply and then you divide by 100. And let's find out what this is. It better start with a 0, guys. So you should be able to do this already. Okay? So 505 times sine of 11 divided by 100. There it is. 9635 ... And your next step would be angle D is sine inverse of that. And here we go. Ready? Second F or shift sine equals 74.49 degrees. That is the angle of elevation. That's how high up she has to turn her head from the horizontal to look. Oh, sorry, David, right, David, to look up. Okay. Question. This is where I come in and throw everything upside down. What if it had asked for the angle of elevation for Eva or Eva? Where's the angle of elevation for her? Is it here? Is it going to be here? We don't have an angle of elevation usually that is obtuse, but it is here. Let's make a dashed line. This is the angle of elevation for Eva, okay? What's the angle? So write this down, okay? Just add it. Elevation for Eva. What's that angle of elevation? Here's the answer. I'm going to find the inside first. Yeah, write it down. We're almost out of time, but I want to finish this. I'm going to start with this one here. Because what are these two angles again? What are these two called? Supplementary. Yes, you remembered. Because your grade 11 teacher taught you all about it, right? So, right, I'm going to find this one and then find this one outside. Because this one is outside the triangle. Okay, let's find that one. Let's go angle E is going to be 180 minus 11 minus 74.49. And I get 94.51. I'm going to use orange. Orange, you're glad it's Friday. Right? I found that one right there. So to find the angle of elevation for her, I'm going to go what? I'm going to go again, 180. 180 again, because side-by-side angles like that are 180. They're supplementary. And I'm going to go minus 94.51. And that's going to give me 85.49. Okay? And I'm going to use pink for that one. And that concludes, for now, sine law. And then once I introduce cosine law, I'm going to mix it up. But remember this, go take this with you for the weekend. How do you know you can use the sine law? Find a pair. If you can find a pair, this is going to be your law, right? Sometimes it's hidden. But if you can figure out a way to come up with a pair, sine law. If not, you're going to have to use cosine law, which I'm going to do next week.